So we've determined that del F equals lambda G if lambda is 1 at the point 1, 0, and at the point -1, 0. So the lambda equals 1 condition says del F equals del G, and in that case del F is just 2I, and del G is 2I. Okay, and you can go back to the equations for del F and del G and see that if X is 1 and Y is 0, you get 2I. And for -1, 0, both of these, del F and del G, turn out to be -2I. So those are your lambda equals 1 solutions. Your lambda equals 3 solutions occur at on this unit circle at 0, 1 and 0, -1. And at both of, at 0, 1, del F is 6J and del G is 2J. So the del F is 3 times del G. At 0, -1, plug in again 0 for X, -1 for Y. You get del G is -2I, del F is -6J, and del F is again 3 times del G. Meaning now, as you go around this circle, that at this point, and this point, and this point, and this point, del F and del G are parallel. Del F being the direction of maximum increase, del G being perpendicular to the circle. We find that at this point, and this point, and this point, and this point, as we move through that point, at the instant we're at that point, there is 0 rate of change of the function f along the curve. Again, because motion along the curve is perpendicular to the gradient, meaning the directional derivative is 0 as we move along the curve at this point. Okay. Now, there's another way that we really want to be able to think about the situation. We were able to find lambda pretty directly without having to actually solve 3 equations. But you see, our situation is once we've determined our gradient and gradient of f and gradient of g, we get equations but we get 2 equations by setting the I components equal, by setting the j components equal. In the equation, del f equals lambda del g. Okay? And the equations were these. Okay? Those are the equations I'm talking about for this present example. That's only 2 equations in 3 unknowns. Okay? You have 3 unknowns, x, y, and lambda. And again, we were able to see that the only lambda values that could work would be 1, and that would work in this equation, log y is 0. 3, which works in this equation as long as x is 0. So we were able to get all of this just by reasoning that out. But to get the points on our curve, you notice we actually used the constraint that x squared plus y squared has to be 1. If y is 0, that means x is plus or minus 1 on this curve, and that's how we got these 2 points. So we used the constraint, or the equation of the curve, if you like. This means that we actually used 3 equations. We used these equations and we used this equation. So really, we didn't have just 2 equations in 3 unknowns. We did have a 3rd equation that allowed us to determine the actual coordinates of the points that we got from reasoning this out. Okay? Now, so in general, you're going to have 3 equations. You're going to have this equation and this equation by setting the I components equal and the j components of the equation, del f equals lambda del g. And the constraint equation, the equation of our curve. Okay? Now, constraint equations won't always be equations of curves because, of course, you can do this for functions of 3 variables. You can't visualize it as well. But you would have x, y, and z variables, and then you would have some constraint on x, y, and z that would allow you to determine the value of all four of the variables that you would have, okay? So, in general, our method then says, set the x components of the equation equal to each other, set the y components equal to each other, and write down the constraint equation, the equation of our constraining curve. Okay, well, we're going to do that now. We're going to do that for a very similar function, but this function is a rotated version of our f of x, y from before, and things are going to be more complicated. Now, we're not going to have, we didn't have time to actually work this through, and there are other things that I've got to move on to. I won't have time to actually work this through, but I've indicated what we do and then how we approach the simultaneous equations, okay? So we'll do this next.